Okay guys, so here we are at Clark Reservation State Park, located in Janesville, New York, just probably 10 miles from Syracuse. And what I want you to pay attention to here is that wherever you go, whether it be a state park or national park, whatever facility or park you go to, there's usually some sort of kiosk or informational stations with really good information, like we have here at Clark, where you'll get some background on the park, like for example the size, in this case 365-acre state park, and when it was formed, why it was formed. It gives you some background on the cultural history, the flora and fauna, also the geological history. So be sure to pause and take notes. Make sure you have a notebook with you as well as your camera. Videos are really good to include as well. So jot down all the information, take pictures of it, take videos, okay? And wherever you go, definitely want to look for that information. There's lots of good information. Remember, you need the geological history background of each of your sampling areas, okay? Information about the rocks in the area, how they formed, their age, any glacial activities, glacial history, fossils present, that sort of thing. So you're going to want to observe everything and take notes on everything. Okay, so here we have what's called Green Lake here in the park, and it is what's known as a cataract lake or a plunge basin for an ancient extinct waterfall. If you look over here towards the northwestern side of the lake, if you imagine going back about 18,000 years ago, where I'm standing right here was an ice sheet, a continental ice sheet that was up to 2 miles thick, if you can imagine. Extremely powerfully erosive agents are ice sheets and glaciers. But as climate warmed 14,000 years ago, that ice began to recede and retreat back to the northwest, back towards the pole. And as it did so, of course, the ice melted and created a very large waterfall. In fact, it's been estimated to be perhaps 2 to 2.5 times the size of Niagara Falls today, if ever you've experienced that. And it persisted for up to 2,000 years. So what it did was it carved out this lake up to 70 feet deep through the relatively soft sedimentary rocks here, okay? So this is the kind of thing you're going to want to be on the lookout for, okay? Again, be very astute in your observations. Take notes on all this information. You're looking for important aspects of the geological history, like this glacially formed waterfall and plunge basin lake, okay? So you may not have evidence of continental ice sheets where you're doing your field work, but certainly perhaps if you get up in the mountains, up in Yosemite, there's lots of excellent examples of glacial activity, glacial work, okay, in Yosemite. And even some of the other mountains, you may find mountain glaciers, cirque glaciers, things like that, that you can certainly observe and note, okay? So those are the kinds of things I'm going to be looking for. Okay, so here we are down into the park a little bit, looking at some of the many layers of sedimentary rock that are indicative of ancient seas that were in this area back during the Devonian period 350 million years ago, okay? How do sedimentary rocks form oftentimes? Well, think about that. They form as sediment is deposited in water environments, oftentimes marine environments, where you have limestones and shales and sandstones being deposited. Now, of course, sedimentary rocks are not always deposited in marine environments or a water-based environment. Sometimes, certainly, they're formed on land. For example, sandstone is often formed by the compaction of sand dunes, okay, where that's where you get your cross bedding going on that's preserved in the rock record. Okay, but oftentimes it is the case. And here in New York, back in the Devonian, it was like the Bahamas. Okay, so we did have shallow seas, warm shallow seas here. And how do we know? Well, because as you walk along here, you find all kinds of fossils of marine organisms like coral. And we know it's a warm shallow sea because coral form or live in relatively clear, shallow, warm seas. Why? How do we know this? Because today's coral are filter feeders, so they can't be living in really murky water. Okay, in order to filter out their food, it has to be pretty clear. So there's all kinds of information you can gain by looking at the fossils. Okay, and we do have fossils here. Now, remember, like I said in the previous video, you can't collect in state parks. At least here in New York, you can't collect in a state park, and you can't collect in national parks. Okay, so you're going to want to look at this material. Now here, you might want to grab something. Well, I don't mean grab it in terms of taking it with you, but you can grab on to something like this and perhaps get up close to it and take a good picture, a couple of good pictures of it, and that might suffice to be able to go back and identify it. But you're going to want to take as many notes as you can. If it's something, again, ideally you want to take something home with you. You can spend time cleaning it up, observing it, working on identifying it, okay? But you can take some of these larger features here and take really good notes, observations in your field notebook, take good clear pictures, and go back and still identify it, and that's okay. Not everything has to be a hand sample. I just prefer most things to be hand samples, okay? All right, now up above, I know there are some what's known as stromatoporids, which are a type of reef-building sponge, but I don't know if they will really come through well in the video, so I will forego that. But let's walk around the other side and look at some good examples of weathering and an erosion that we can look at, okay? Hang with me just a minute. Okay, so here we are now over on the other side. If you look right over there is where we were, and now we're over towards the northwest side where the waterfall began to create the lake. Now, if you can see through the fence there, but right below me is Green Lake. Okay, so what I want to show you over here is a great example of erosion and weathering. If you look at this rock, maybe a little tough to see in the video, but this is limestone I'm walking on. It's limestone that's 350 to 360 million years old, formed when the ancient sea was here. And what it is extremely bumpy, okay, what we might call hummocky. Okay, it's got a hummocky nature. And if you've ever looked at the bottom of a stream in the summertime, if you look through the water, if it's shallow enough, and look at the bottom, this is kind of what the bottom might look like, kind of hummocky, kind of bumpy from the water going over and disturbing the sediment on the bottom and creating this sort of look. So how did this form? Well, again, if you think about the ice sheet that was here and the ice that melted and the torrent of water that must have poured over these rocks 12, 13, 14,000 years ago as the ice melted and retreated, then you have a pretty good sense of that this was the floor of a river, okay? A very fast-moving river. So it created this bumpy nature, okay? And some other great examples of weathering we have, let's go back over here, so it's a great erosional example, but if we go back over here, we come up a little bit, we'll look at some cracks in the rock that, yes, formed through some faulting activity that occurred here, okay? So there was a lot of tectonic activity, faulting, that occurred many years ago that created many of these cracks that you see in the limestone. But also, after these cracks were originally formed, what happened was you have mechanical weathering occurring. you have what's known as frost wedging, where the water gets in. A great example today. It's nice and cold. Ice gets in, or water gets in, it freezes. What happens when ice or when water freezes? It expands, and it's very forceful, very strong, and it starts breaking the rock apart. Okay, so initially you had faulting going on. It created these cracks in the rocks, okay, these fractures, but then was aided by frost wedging, a physical mechanical weathering process. Okay, so these are kinds of things, again, you're going to want to look for and document in part 2 of your assignment. Now, Clark Reservation is an awesome place to do this. It's got terrific geology, but you can find similar things wherever you are, okay? It may take a little bit longer. So one thing you might want to do if you're looking for a place is to contact your state geologist, okay? Every state has a government geologist, okay? Look up their number, their email, find their webpage, and contact them and ask them for places you could go. It seems, sorry guys, seems I was cut off there. So contact your state geologist office and see what help they can give you in terms of finding locations to conduct your assignment, and also in terms of the geological background information. They can be very helpful to giving you some resources to help you with that background research. Okay, so your state geologist office you're going to want to visit. Okay, all right, now I've actually gone the other way now. I want to show you another example of weathering, a chemical weathering example, but it's not, hasn't melted enough here. I was hoping it might be a little more melty, but in this rock you'll find little shallow depressions almost any time, but particularly after it melts a little bit, the snow melts, or when you have some rain. And what happens is that water, this being limestone, okay, made of calcite, if you get a little water, okay, it has, not only is water a good erosive agent, but you add a little carbonic acid, which is simply rainwater mixing with CO2 in the atmosphere, produces some carbonic acid, a very weak acid, but it really speeds up the erosional process. This is how caves and caverns are formed. And you'll see little depressions here in the limestone. And eventually, if you come back thousands of years from now, that'll be a little cave or cavern as it continues to erode its way through the limestone. So those are the kind of things you want to look for. If you see the bowls of water, depressions on rock, perhaps that's limestone, okay? Again, you should carry a little vinegar with you, and you can test out to see if you have limestone, or marble for that matter, by dropping some vinegar on it and see if it bubbles, okay? All right, cool. I hope this has been somewhat helpful to you, and again, ask questions as they come up, and send me bits and pieces as you go along, and I'll give you feedback. And again, don't wait, start early. All right, guys.